All right. Yeah. Right. Good morning, students. Last class we completed mass percentage, volume percentage, mass by volume percentage. Till that we did no yesterday. Had everyone revised that yesterday? So write today's date. Now we discuss next mole fraction. Right heading mole fraction. The fourth concentration term, mole fraction. Right. Now see, mole fraction is represented by the symbol what a chi. Now what is mole fraction? See, suppose two components are there, A component and B component. Then mole fraction of A component I want from these two components. Then how do we get C? Mole fraction of A is given by number of moles of A by number of moles of A component plus number of moles of B component. So what we define for mole fraction, it is simple. It is the ratio of number of moles of one component to the total moles of both the components. Same way mole fraction of B component if I want, how I get mole fraction of B? It is the ratio of number of moles of B component, that is number of moles of B by total moles of A plus B. So this is how we get mole fraction of B component. Hence what we define for mole fraction, right definition, it is the ratio of number of moles of one component. It is the ratio of number of moles of one component to the total moles of all the components. So this is the definition of mole fraction. Understood, friends? Simple. So in order to get mole fraction of any one component, we take number of moles of that particular component in the numerator by total moles of all the components in the denominator. Understood all of you? Copy this. And is it temperature dependent or temperature independent means there is no volume term, no? So in exam they ask you which concentration is temperature independent. So here we write it is temperature independent. And does it have any units they ask in exam? See ratio, do it have any unit? No, no. So as you know here we are taking only ratio. So it doesn't have any unit. Write that it has no unit. Copy this. Clear for all? So simple no, mole fraction is nothing but it is the ratio of number of moles of one component to the total moles of all the components in a solution. And write this relation. And mention here what is Na number of moles of A component. What is Nb number of moles of B. Mention the terms. And see one more important, this chi A plus chi B, that is mole fraction of A plus mole fraction of B will always be unity. The sum of mole fraction of both components should be equal to what? 1. Mole fraction of A component plus mole fraction of B component will be equal to 1. Copy this. Are you following, students, everyone? So be regular, as I told you in the day 1 itself. So, and revise the concepts on the day what we teach and work on the questions from study material. And everyone buy NCERT textbook. You have to follow NCERT 100% because within NCERT only they are asking questions in JEE mains as well as in NEET. So try to solve questions from the day what we teach here. Clear no more mole fraction is nothing but ratio of number of moles of one component to the total moles of all the components. It is temperature independent. Why? Because there is no volume term. And does it have any unit means there is no unit for it. Copied all of it. Simple. Now write one question on it. Now I am giving one question. See, write this question. 0.6 gram of urea. Now, what is the formula of urea? Urea, you know, it is an organic compound, NH2CONH2. This is called urea. We use in fertilizer. He is present in 36 grams of water. 36 grams of water. Then find the mole fraction of urea. Copy this question. Understood? 0.6 grams of urea given to you, and this much urea is present in 36 grams of water. It is present. So what is will be the mole fraction of urea? You have to find mole fraction of urea. Now, what is the relation, student? Mole fraction of urea to get what we have to consider number of moles of that particular urea by number of moles of urea plus number of moles of what? Water. Correct? Mole fraction, that only we learned it is a ratio of moles of what the component we want, that we take in the numerator. Denominator, sum of the mole fraction moles of urea plus water. Now see, student, had he given moles to you directly in the problem? Moles he has not given. What he has given? Mass given. And you people learned mole concept. How you get moles? By knowing mass. So this mass we have to divide with molar mass. In order to get what? Number of moles, we learned in mole concept in the previous class. Now find out the molar mass of urea. How much it comes? 14 into 2, 28, 28 plus 4 from hydrogen. 28 plus 4 plus 12 plus 16. Add the atomic masses, you will get 60. So see, then mole fraction of urea, check whether you are getting 60 or not. This mass what we got given in the problem, 0.6, that is to be divided with 60 by 0.6 upon 60 plus what is the mass of water given? 36. What is the molar mass of water, students? Molar mass of water is 18. Now simplifying this, how much you get? This will cancel 0.1, this will cancel 10. Is it coming 0.01? 0.1 upon 10 means 0.01. So this also comes 0.1 upon 10. This comes 0.01. This 18 will cancel by 2 times. So mole fraction of urea, how much we get? Check. This comes to 0.01 upon 0.01 plus 2. That comes how much, student? 0.01 upon 2.01. You have to add 2 plus 0.01, 2.01. Check, everyone, you got the same answer. 0.01 by 2.01 you have to get. Or can I write this as 1 by 201? This mole fraction can be written what, student? Mole fraction of urea, we can write it as what? 1 upon what? 201. Do you agree? This 1.01 can be written as what? 1 upon 201. So in option, if they give 1 upon 201, you can opt that, or you have to simplify this. So simplify this and find out answer how much you get. 1 upon 201. That will be mole fraction of what? Urea. Copy. Clear and simple, no? Understood, everyone? The mole fraction of urea to get what we have taken, number of moles of urea by number of moles of urea plus water. So moles he has not given. What we are doing here, mass by molar mass. Molar mass of urea is coming how much? 60. So 0.6 upon 60 by 0.6 upon 60 plus 36 by molar mass of water is 18. Simplifying that, you get 0.01 by 0.01 plus 2. That comes how much? 0.01 by 2.01. So that can be taken 1 upon 201. If option is given 1 upon 201, you have to opt that, or you have to simplify that. Simplify that and find out what will be the answer. Suppose mole fraction of water would have been asked in the same question. What will be mole fraction of water means what you do? Since mole fraction of urea plus mole fraction of water will be 1, no? Sum of the fraction of two components should be equal to 1, no? Then mole fraction of water to get, what you do, student? From 1 minus 1 by 201 you cancel. Take LCM. 201. This is 201 minus 1. That comes how much? 200 by 201. check is it option coming 200 by 201 or not. That will be mole fraction of whom? Water. Because mole fraction of two components will be equal to 1, no? So examiner wish, he can ask either mole fraction of your solute or he can ask mole fraction of solvent. Following students, everyone? Simple. No. Only thing is we have to know what is mole fraction and mole. We have to bring from mass. Mass by mole. Molar mass will give number of moles. Completed. Yeah. Right. One more question. Second question. See, find the mole fraction of NaOH. 40% W by W. What is W by W, students? Mass percentage of aqueous NaOH solution. Aqueous means what? Which is present in water. Question understood? What will be the mole fraction of 40% mass percent? You know what is mass percent? Last class we discussed. Students know what is 40% W by W mean. Tell me what we learnt in previous class. 40% W by W means 40 grams of caustic soda is present in how many grams of solution? 100 grams of solution. Correct? But what we require here, solvent weight we require. Who is solvent here? Water. Your aqueous. But had he given water to you directly? No, no. Mass of solute we know 40. Mass of solution we know 100 grams. Then how do we get mass of solvent? So in order to get mass of solvent, what you do from 100 grams of solution, subtract 40. That gives weight of solvent. Understood? So here write weight of solvent. How do we get from 100 grams of the solution, subtract 40 grams of solute? That gives 60 grams of what we are getting, friend. Water mass we are getting. Now mole fraction of whom he wants? NaOH he wants. Now tell me mole fraction of NaOH to get what we take number of moles of that particular component by total moles. That is number of moles of NaOH plus number of moles of water. Now moles of NaOH, how do we get? We know the mass. Mass is 40. What is the molar mass of caustic soda? Find out. 23 plus 16 plus 1. 23 plus 1, 24. 24 plus 16, that comes to 40. So 40 is the molar mass. 40 by 40. And in the denominator also 40 by 40. Plus water weight, how much should I take? 60. Here many students will do mistake by taking 100. 100 is not the weight of solvent. 60 grams. So 60 is to be divided with what? 18. Molar mass of water is 18. Then this 40 will cancel one time, this 40 will cancel one time, and 3 multiple will cancel, or 6 ones are, 6 threes are, 6 ones are, 6 threes are. So 10 upon 3, that comes how much, student? 1 by 1 plus 10 by 3. Now take LCM for this. That comes how much? 1 by, this will be 3, no? 3 plus 10, that is 1 by 13 by 3. 1 by 13 by 3, that is 1 by 13, 1 upon 13 by 3. 1 upon 13 by 3. That comes how much, students? That comes 3 by, this will be the answer. So copy this 1 by 13 by 3. Simplify this. So how much you get? 1 upon 13 by 3. Simplify this. 1 upon 13 by 3 we get. Check answer all everyone. Take LCM of this sum. 1 by 1 plus 10 by 3. That comes 1 by, this will be 3, no, 1 3 is 3. 3 ones are 3. 10. So this comes how much? 3 upon 13. Divide 3 upon 13. That will be the mole fraction of NaOH in 40% of NaOH. Understood, students? Copy this. So here, students, you have to be careful. Weight of solvent to get what we do from 100. Don't forget to subtract 40. That will give mass of what? Solvent. How much weight of solvent we are getting? 60 grams. So 60 is to be divided with what? Molar mass. Molar mass of water is how much? 18. 40 upon 40 by 40 upon 40 plus 16 up 60 upon 18. That comes how much? 1 by 1 plus 10 upon 3. Take LCM for this. You get 1 upon, that comes 3 by 13 you get. Check answer. If option is given 3 by 13, opt 3 by 13, or you have to simplify that. Understood? This is what mole fraction of, what mole fraction is a, what is mole fraction? Number of moles of one component by total moles of all the components. Now write next concept, molality. Clear, friends, all of it? Next, write molality. Till now, what are the concentration terms we studied? Mass percentage we learned, volume percentage we learned, mass by volume percentage we learned, mole fraction we learned. Now write molality. Molality. Fifth concentration term, right? Molality. Molality is shown by the symbol what? Small m. Now what is molality? Say the number of moles of solute present in 1 kg of solvent. Right, definition. The number of moles of solute, the number of moles of solute present in 1 kg of solvent. This is what we define for molality. Understood? So molality is nothing but how many moles present in 1 kg of the solvent. So mathematically how we write molality is given by number of moles of solute upon weight of solvent in kg. Weight of solvent in kg. This is the relation for molality. Keep it in box. So molality is given by number of moles of solute by mass of solvent in kg. Now what will be the unit for molality? If molality units would have been asked, simply we write small m, that means molal, or we can even use mole per kg. We can even write mole per kg. Either molal we write or mole per kg. Now, is it temperature dependent or temperature independent would have been asked. Since there is no volume term, so it is temperature independent. Right, that it is temperature independent. Why? Since there is no volume term. Understood, students? So in exam they ask you which concentration is temperature independent. Still no temperature independent, mass percentage in temperature independent, and what else? Mole fraction is temperature independent, molality is also temperature independent. copy dollar. Now see, in place of number of moles, what we write? Number of moles, how do we get? Mass of solute by molar mass of solute, no? So now I am elaborating this. In place of moles of solute, number of moles, what we write? Mass of solute by molar mass of solute. Okay, next relation, right? This molality can be written further what? In place of moles of solute, what I am writing? Mass of solute. No, moles, how do we get, student? Mass of solute by molar mass of solute. Getting idea, all of you? In place of moles, we are writing mass of solute by molar mass of solute into 1 by weight of solvent in kg. Weight of solvent in kilogram. This is the relation. That means in the problem, mass of solute will be given, mass of solvent will be given. Molar mass we can find out from the substance. And place this relation in box. This is important relation. Sometimes the mass of solvent may be given in grams. Instead of kg, they give in grams. Then you have to convert the grams into kg. Then what is the relation? As you know, 1 kg, how many grams? 1000 grams, no? So then what should I write? Mass of solute by molar mass of solute, molecular mass of solute or molar mass of solute into 1000 upon weight of solvent in grams. When we take this relation, students, if it is given in grams, copy this relation. These two relations are important. So in the exam, they give you mass of solute to you. Weight of solvent, if they give in grams, use this second relation. We are following everyone. Now write one question on molality. 0.53 grams washing soda. What is washing soda? Sodium carbonate we call washing soda is present in 500 grams of solvent. Then find its molality. Now question understood. Mass of solute given to you. This is what? Sodium carbonate. How much mass given? 0.53 grams given. That is present in how much weight of solvent? 500 grams of solvent, and he wants to find molality. Now tell me what is the relation? Once see the relation. Molality, what we wrote? Mass of solute, no? What is the mass of solute given to you? 0.53. By molar mass of solute. Find out molar mass. You have to be thorough with atomic masses. I told you to recollect 20 elements. Sodium atomic mass is how much? 23. 23 into 2, 46. 46 plus 12 plus 16, 3 is 48. Total when you add, it comes, check how much you get. 106. 23 to 46 plus 12 from carbon. That is 58. 58 plus 16, 3 is 48. 8 plus 8, 16. This is coming 106 or not? Check everyone. Molar mass by adding algebraic sum 106 you have to get. But see here, solvent weight is not given in kg, grams given. So 500 divided by 1000. 1000 goes in numerator because we have to convert the mass grams in kg. Now this 0, 0, 0, 0 cancel, 5 will cancel by 2. 53 cancellation value can be taken 106. 106 will cancel 53 by 2 times. So this makes 10 power minus 2 by 2 times it gets cancelled. 2 to get cancelled. So answer comes 0.01 molal. Check answer is coming 0.01 or not. On simplification you have to get 0.01 molal. Unit you have to mention small m, or you can even write mole per kg. Understood, students? Simple, no? So molality is nothing but number of moles of solute present in 1 kg of solvent. Here since mass is not given in kg, we have to convert the grams into kilograms. Understood? Copied all of it. Now write next, one more question you write. Find the molality of 40% W by W aqueous NaOH solution. Aqueous NaOH solution. Now question you understood what I am asking to find molality I am asking, and I have given 40% W by W. What does 40%? Just now we learned. 40% W by W means, what does it mean, students? Mass percentage. That means 40 grams of NaOH is present in how many grams of solution? 100 grams of solution, no? But molality, to find what we require, weight of solvent we require. Is it right? Number of moles present in 1 kg of solvent, no. But had he given weight of solvent to you directly? No, no. So what we do in order to get weight of solvent? So in order to get weight of solvent, don't forget, many students do mistake. They take directly 100. If you take directly 100, answer comes wrong. For solvent weight, to get what we do from this solution weight, to subtract 40. That comes how many grams? 60 grams is the weight of solvent. Now I know the mass of solute to be 40 and the weight of solvent to be 60. Then find out molality. Molality is given by 40 is the weight of solute from the mass percentage. Molar mass is 40 but weight of solvent is 60. That means here what should I write? 60 by 1000. 1000 goes to numerator. Now 40 40 get cancelled. This 0 0 get cancelled. I am cancelling with 2 multiple. 2 3s are 2 50s are. Divide 50 upon 3 in the rough work. So when you simplify 50 upon 3, 3 multiple, 3 1s are 3, 0, 3 6s are 18. And here when you cancel 0.06, this comes 18, 6 bar. That means the answer to come 16.66 molal. Check, everyone got same answer, 16.66 molal or mole per kg. So here student, you have to be careful because solvent weight he has not given. If you don't subtract, your answer comes wrong. Just generally student, what you do, you take 100 upon 1000. So that makes answer wrong because here weight of solvent he has not given. Weight of solvent, to get what we are doing from the solution mass, you have to subtract the weight of solute. Understood student, all of you? Now write next heading, relation between, right, one, there is a relation between, important in exam point of view, relation between molality. Molality is shown with what? Small m, and mole fraction of solute. Relation between molality and mole fraction of solute. So one important relation is there, make a note. There is a simplified formula for relation between molality and mole fraction. See, what is that relation? Molality is equal to mole fraction of solvent by mole fraction of solute into 1000 by 18. 18 is what? Molar mass of water. This is the relation important in exam point of view. They ask you to find mole fraction of solute by giving molality. And here water is taken solvent. See, is water solvent? No. So molar mass of water is taken 18. If it is benzene, you have to take it molar mass of benzene. So depends on the nature of solvent. And there is one more simplified formula for this mole fraction of solute. You can use either of these two relations. Mole fraction of solute is given by molality plus 55.5. You can use either this relation or this relation. Both relations are same between mole fraction of solute and molality. So important in exam point of view, they are asking relation between molality and mole fraction of solute. Copy this. Following student, write one question. Once in exam they ask a question like this, right? Find the mole fraction of solute. Mole fraction of solute in 1 molal aqueous. Aqueous means he is mentioning water. NaOH solution. The question, understand what I am asking. What will be the mole fraction of solute? We have to find mole fraction of solute in 1 molal. Molality given 1 molal in aqueous NaOH solution. Now, what is that relation we wrote? One simplified formula we wrote. The second relation I am taking. Mole fraction of solute is equal to molality by molality plus 55.5. How I got this 55.5? 1000 divided by 18. 1000 how I got the volume for 1 liter is 1000, no, density is 1 gram per cc. So 1000 by molar mass 18. Simplifying that we get 55.5. Now mole fraction of solute is to be unknown. This is unknown. We have to find out this. Molality given 1. Getting idea all of you. So mole fraction of solute in place of m, what should I take? 1. 1 plus 55.5. That comes how much, student? 1 by 56.5. Or can I write this as 10 upon 565? So in the option 10 upon 565 is given, you can opt that, or you have to simplify this. Simplify 10 upon 565 and check how much you are getting. So this has been asked in exam. Mole fraction of solute they will ask you, and they give molality. Clear, students? Are you following our notes? So this is what a molality, relation between mole fraction of solute and molality. Now write next term, molarity. The other concentration. Till now, what are the concentrations we learned? Mass percentage, volume percentage, mass by volume percentage, mole fraction, molality, and relation between molality and mole fraction just now we wrote. Now write next heading, molarity. Molarity. Molarity is shown with the symbol what? A capital M. Now, what is the difference between molality and molarity, student? Molarity is the number of moles of solute present in 1 liter of solution. So, what we define for molarity? Number of moles of solute present in how much volume of solution? 1 liter of solution. Present in 1 liter of solution is known as molarity. So the difference between molality and molarity. Molality, what we wrote, number of moles of solute present in 1 kg of solvent. Here it is for 1 liter of solution. So molarity is given mathematically by what relation? Number of moles of solute upon volume of solution in liter. Volume of solution in liter. This is the relation for molarity. Keep it in box. Now what will be the unit for molarity? Unit, if they want to see, unit simply we write capital M. Capital M means what? Molar, or you can even write mole per liter. Anyway, either capital M you can mention or mole per liter. Now, is it temperature dependent or temperature independent? Means see, there is a volume term here, so surely temperature will have influence, right? It is temperature dependent. Understood? Now, we elaborate this further. See, number of moles of solute, what we can write, student? Mass of solute by molar mass of solute, no? So, moles, how to get moles, what we do? Mass by molar mass. Now, we expand this relationship. Pop it up here, everyone. Now, we write one more relation with this expansion of this molarity. What we write? Molarity is given by mass of solute by molar mass of solute into 1 upon volume of solution in liter. This is the relation. So in the problem they give you mass of solute to you, volume of solution to you in liter, then you have to relate this relation. The problem mass of solute will be given, volume of solution will be given, and you have to see whether it is given in liter or not. Sometimes they may give in milliliter. Then what you have to do, you have to convert milliliter into liter. 1 liter, how many ml? 1000 ml. Then you have to relate this relation mass of solute by molar mass of solute into 1000 by volume of solution in milliliter. When we take this relation, if they give volume in milliliter, so the second relation we have to apply if volume is given in milliliter. Copy these two relations. Here student following everyone. So this is what molarity. Write one question. See, molarity in exam we get questions like this. Write 6.02 into 10 power 20 molecules. These many molecules of urea are present in 250 ml of solution. Then find its molality. Find its molarity, capital M. Question understand. Say these many molecules of urea has been present here. In how much volume? 250 milliliter. For this, what will be molarity? Now think student how you approach. Molarity means what we want, number of moles we want, no? But in the problem, had you given number of moles to you directly? No, no. And how you bring given molecules into moles, mole concept you learned no previous class. If I take 1 mole of urea, how many molecules will be there in 1 mole urea? 1 mole of urea will have how many molecules in the mole concept we learned previous class? Can I say 6.023 into 10 power 23 molecules will be there? Do you agree? These many what will be present student molecules will be there, no? Now for 1 mole if it is having these many molecules, the molecules what he has given in the problem that you equalize here. So to for 6.02 into 10 power 20 molecules, how many moles it will weigh? So how you bring the given molecules into moles? Given molecules you divide with Avogadro number. So this is the given molecule. That means number of moles to get what we do? The 6.02 into 10 power 20 molecules what he has given in the problem, that we have to divide with Avogadro number. As you know, 1 mole of any particle contain Avogadro, we learnt in the previous class. So they will link up with mole concepts here. So the 6.02, 6.02 get cancelled, 10 power 23 bring numerator. That comes how much? 10 power 23 minus, that comes 10 power minus 3. These many what we got? Moles we got. Now molarity we to find we require moles only, no? Now indirectly moles we brought. Now molarity is equal to what should I write? Number of moles we found 10 power minus 3 by volume. Volume is not given in liter. 250 given. So 250 I have to divide with 1000. So 1000 means can I write 10 power 3? 10 power 3, 10 power minus 3 get cancelled. That comes how much? 1 by 250. So divide 1 upon 250, that comes how much? 1 upon 250 comes 0.00, so it will cancel by 254 are 5 4 are 20, 2 4 are 8, 10, and one more 0. That means 4. Is it coming? 0.004 check. 0.004, these many what it is? Molar. So understood. So directly see moles he has not given. What we are doing, these molecules we have to bring in moles. By what way we can bring given molecules divide with Avogadro number. Clear student, following everyone? What I am teaching, are you catching my point? What I am under till now what I am teaching? Clear no? So understood. So what we are doing here, molecules we brought into moles. Then we divide with what? Volume given. Volume is given in 250 ml. Right, one more question. 0.49 grams of sulfuric acid is present in 500 ml solution. Then find its molarity. Question, mass given. How much mass for sulfuric acid? 0.49 grams given. That much mass is present in 500 ml. For this you have to find molarity. Now what is the relation we wrote? Molarity is given by mass of solute. Mass is given 0.49 by molar mass. Find the molar mass of sulfuric acid. You are familiar last class how to find that each hydrogen is 1. 1 into 2, 2 plus 32. 34. 34 plus 64. That comes 98. No, check 98 is coming. 98 is the molar mass. But volume is not given in liter, milliliter given. So you have to convert the milliliter into liter. 500 upon 1000. The 0 get cancelled, 5 will cancel by 2. 49 will cancel 98 by 2 times. But decimal is there, I am removing the decimal. 10 power minus 2 by 2, 2 get cancelled. Check, is it coming 0.01 molar? Answer should come deci. This is called centimolar. 1 by 100. Sometimes they use the terminology centi, deci, deca. So make a note what is meant by semimolar. Semimolar means what? Half. 0.5 molar. What is decimolar? Deci means how much? 1 by 10. 0.1 molar. In exam they use this terminology. And millimolar. Milli means how much, student? Milli is 10 power minus 3. 0.001 molar. And decamolar. What is deca? Deca means 10. 10 molar. These terms they use in exam. Semi, deci, milli. This is how much we are getting? Centimolar. Centi means 1 by 100. Following students, everyone, molarity, what is molarity till now, right? Right, next question, right, last 5 minutes. Relation between copy them all of semi, deci, milli, deca, centi. And the answer we got centimolar. This is 0.01. Now, right, next, relation between molarity. Molarity is shown with what? A capital M. Mass percentage. In NCRT and in JEE mains NEET, they are asking related with this, and density. There is a relation between molarity, mass percentage, and density. So in the problem, they give you mass percentage to you, density to you, and they ask you to find molarity. Now, what is that relation? See, molarity is given by percentage mass into 10 into density by molar mass. This is the relation to find molarity by knowing mass percentage and density. This is mass percentage into 10 into density by molar mass. This is important relation. Write one question. Now see in exam how they ask concentrated sulfuric acid. Concentrated sulfuric acid having 98% mass percentage and its density and its density and its density is 1.8 gram per cc. Density of sulfuric acid given 1.8 gram per cc. Then find its molarity. Then find its molarity. Question C, mass percentage of sulfuric acid given 98%, density of sulfuric acid given 1.8 and asking to find molarity. Direct substitution, find out molarity is equal to percentage given to us 98 into 10 into density, how much for this 1.8. And find molar mass for sulfuric acid. How much you get molar mass? That is 2 plus 32 plus 64. 98, no? So 98 get cancelled. Answer comes how much? 10 into 1.8 means it is nothing but 18 molar. So answer is 18 molar. Now think over without formula. I don't know about this formula. Then how we got this relationship? Tell me what does 98% W by W mean? I write here 98 grams sulfuric acid is present in how many grams of solution? 100 grams of solution, no? Do you agree? 98% W by W means what does it mean? 98 grams sulfuric acid is present in 100 grams of solution. Density given. Density given means something to do with density. Density is given by what? Mass by volume, no? So density is given 1.8. What is the mass of solution? We know 100 by V. V is what? Volume of solution I am finding. Now volume of solution is coming how much, student? 100 by 1.8, no? This will be in what unit? Milliliter. Getting idea all of you. This volume I got 100 by 18. Now molarity we want to find. Now see I am writing here. Molarity is equal to number of moles. That is mass. Mass is 98 by molar mass is 98 into volume. Volume we got in milliliter. So milliliter you have to convert in liter. That means see what I am writing, this 100. 100 I wrote here. 1.8 goes to numerator into 1000 because we have to convert in liter, no? Now this 0 get cancelled and check whether we are getting the same relation or not. See, mass percentage into 10 into density by molar mass. Answer comes same. This is the relation. So percentage they given, density they given. Direct you apply the relation. Percentage into 10 into density by molar mass. Everyone following what I am saying? See, answer in this way also we get the same without formula using. That means here mass percentage is what? 98 grams present in 100 grams of solution. Density is what? Mass per unit volume, no? Density is 1.8, mass of solution is 100. From this we found volume of solution. Volume of solution is coming 100 by 1.8 milliliter. Now molarity means what we wrote? Mass. Mass is 98 by 98 into volume. This volume I substituted here. 100 by 8, 1.8. 1.8 gone to numerator into 1000. Now the same relation what we wrote here. Percentage is 98. 10 into density. Density is 1.8 by molar mass. So today we conclude here, we stop here, and tomorrow we continue with molality, and next we go into another concept. So today what you do, once you revise all this till molality and work on questions related on weight mass percentage, volume percentage, mass by volume, molality. Okay students, I am ending the class. Wish you all the best. Bye.